All right, so today we're going to talk about compound inequalities. Okay, we're first going to warm up with a few regular inequality problems just to kind of get our brains working until we get up to our compound inequalities. Please have a piece of paper out. I'm going to be checking it to make sure all of your work is shown. Okay, write down problems 1 and 2 on your piece of paper, please. Okay, pause the video if you need to get up and get a piece of paper out. Okay, and I want you to then take a minute, solve the problem, and then restart the video. Okay, and check your answers with my work. So pause right now. All right, so when we're solving inequalities, we pretend just like there is an equal sign instead of the inequality sign. So I'm going to first divide by 3 because I want to get x all by itself. Okay, so my final answer, x is all by itself, I get x is less than 4. So if I graph 4 on my number line, okay, I can write the rest of my numbers if I want to. And then I have an open circle, and it will be going to the left. Okay, number 2, same idea. I want to get my x all by itself. So I'm first going to divide by a -4. And what happens when we divide by a negative number? We flip our inequality sign. Okay, so we end up with a -9. Okay, so x is less than or equal to -9. So if I graph -9 on my number line, it would be a closed circle, and this will also be going to the left. Okay, now if you haven't already, okay, please pause the video to write that stuff down. Okay, and I want you to pause the video again and complete 3 and 4. Okay, so pause right now. All right, so solving inequalities again. Okay, this time it's a 2-step equation, not like a 1-step in our first problem. Okay, so I'm going to subtract 9 from both sides. So I get 14 over here. Okay, and then I have my 2, so I'm going to divide by 2. So I get x is less than or equal to 7. And that would be a closed circle at 7. Okay, and it would be going to the left. Okay, for number 4, who remembered distributive property? Nice job. Give yourself a pat on the back if you remembered. Okay, we get a -3x and a -12. Okay, we took 3 times x, or -3 times x, and -3 times a +4 is less than -15. Okay, now we're just going to solve regular. We're going to add 12 to both sides. So I get -3x is less than -3. Okay, I'm going to divide by a -3, and what happens when we divide by a negative? That's right, flip-flop the sign. Okay, we have an open circle at 1, and this time it's going to be going to the right. Okay, take a moment and write this stuff down if you have not done so already. Okay, moving on to compound inequalities. Okay, on your notebook sheet of paper, please write compound inequalities. Okay, maybe underline or circle it. Okay, put it nice and big so you can look back on it when you need to. Okay, and I have 2 examples up here of 2 different types of compound inequalities. Right, if we look at example number 1, okay, notice that our graph looks a little different than what we're used to when we're graphing inequalities. Okay, notice we have a starting point and a stopping point with the graph in between the two. Okay, if we look here, okay, it says 2 is less than or equal to x, and x is less than or equal to 4. Okay, and how I like to graph it, okay, is I like to split it up into 2 separate problems. So I do the first part, 2 is less than or equal to x, and then x is less than or equal to 4. Okay, and anytime you see it set up like this, where we have x or our variable in the middle, okay, it's kind of going to look like a dumbbell up here, where there's going to be 2 dots, okay, 2 points, and the line is going to be going between the 2 points. Okay, so if you want to have this example just written down, okay, that's fine. Okay, if we look at example number 2, how it's different than example number 1, notice we have an or statement between. It says x is less than or equal to -3, or x is greater than 5. Okay, and just like we did with our regular inequalities, okay, we will still graph them the same way. Okay, but if you notice here, the graphs are going in opposite directions. Okay, and that's how it's going to look for when we see this or sign here. Okay, we're going to have one point going in one direction, and then we're going to have another point going in the other direction. Okay, so make sure you kind of notice the differences in the problems, okay, that you can easily tell what graph you're going to be graphing for these compound inequalities. We'll be going through some problems, okay, but make sure you write these down, okay, so you at least have something to look back on. All right, so we're going to start with these 4 examples. Okay, so if you want to pause the video to take a minute to write down 1 and 2, okay, and then we can go through this together. All right, so for number 1, okay, like I said in the previous slide, how I like to split it up into 2 separate problems, where I get 4 is less than x, and then I also have x is less than 7. Okay, so again, we're going to have our points. That's the first thing you should do. I know that at 4, it's going to be an open circle, so I can do that right away. Right? And I also realize that, oh, at 7, it's also going to be an open circle. Okay, and if I look back on our notes from the last slide, notice that when we have this x in the middle, like this, that our graph looks like a dumbbell. See how it looks like a dumbbell? They're kind of between. Okay, so I know that my line here is going to be between my 4 and my 7. So I can just draw it like that. Okay, some people like to actually draw their lines using these 2 examples that I have up here. Okay, it's up to you. Okay, I just like drawing my dumbbell right away because I know that's how it should be. All right, for number 2, okay, again, I'm going to have an open circle at -1. Okay, and I know that at 4, I'm going to have a closed circle, right? Because anytime you have that equal to beneath it, it's going to be an closed circle. Okay, and I see here how my x is between my 2 numbers. So I know I'm going to have that dumbbell, like I talked about earlier. Okay, now take a minute. If you need to write these down, please do so. If you haven't written down 3 and 4, pause the video and do that now. Okay, for number 3 and 4, notice we have this or statement. Okay, the or statement, if we look back on our previous slide, okay, see how our graphs are going in different directions here. Okay, so we're going to kind of think about that idea as we're graphing for these ones. Okay, so for number 3, I'm first going to do my circles, okay, because I know how to do that. Okay, I'm going to have my open circle at 1. I'm going to have my closed circle at 4. Okay, and since we have our or statement, okay, I'm going to have my graphs going in opposite directions. Okay, now you can also think about it as you can put your favorite numbers in, right? Like I've talked about before. If my favorite number is 5 less than 1? No. So I don't want this graph going towards the 5. I want to go the other way. Okay, it doesn't work. Okay, now over here, if I have 5, is 5 greater than or equal to 4? Well, yeah, so I want to go towards my 5 on my number line. Okay, so even if you don't remember the graphs like in the first couple examples, you can still figure out what direction they're going. All right, so for number 4, okay, I'm first going to do my circles. Closed circle at -2, because I have that equal to sign, and an open circle at a +3. And since I see that or statement, okay, I know they're going to go in opposite directions. Okay, so we can draw them like that. All right, now we're going to go backwards. We're given the graphs, and our job is to write the equations down. Okay, now remember, when we have our dumbbell, we always have our x in between. Okay, and I know one of my numbers is 3, and my other number is 6. So I can write 3 and 6 down. Okay, now if we look back on previous examples we've done, okay, notice that our signs are always going in that same direction. Okay, if we look back on even the first example, notice they're always going in the same direction. Okay, so if I'm drawing my graphs here, okay, I'm going to have them going in the same direction. Now, would I have the equal to sign underneath? How do I tell? Well, closed circle here, closed circle here, so I know I'm going to have that equal to sign there. Okay, for number 2 over here, again, it's my dumbbell kind of look here, so I'm going to have my x between. I have a 4 and I have a -2, so I can just jot those down. Okay, I know that my inequality signs are going to be going in the same direction. Okay, but notice here I have a closed circle, and here I have an open circle. So I'm only going to put my underline on the one next to the 4. All right, then notice we have our or ones. They're going in opposite directions. So I'm going to have x and 1 or x and 4. Now let's look back on our inequality signs for the or statements. Okay, if we look at our or statements, notice that they're always going in opposite directions. Opposite directions here. Okay, and if you look even back on our first example, again, they're going in opposite directions. Okay, so I'm going to put mine in opposite directions. Okay, and which one would have the underline on it, the equal to? Well, that would be 1 because it's a closed circle. Okay, same for number 4. I'm going to have an or statement because they're going in opposite directions here. I'm going to have a 0 and I'm going to have a 1. So x and 0 and x and 1. Okay, they're going in opposite directions, so that means the inequalities are also going in opposite directions. Okay, now do either of them have underlines? No, because they're both open circles. So this would be my final answer for that graph.